So in this case, okay, I'm going to show you where we're supposed to go. Okay, this is the meeting area that we want to show to the user. Okay. So in our sample, we just do some scaffolding stuff. This is just to make sure that the building is loaded, and to pop up a reminder in case we didn't load it. This is to make sure that level 2 is visible, similar to what we saw just now. And this part of the code says that we want to look at the target from a distance of 5 meters, and the target we want to look at are these 3D coordinates. Okay, in case you're wondering how these numbers came about, I'm just giving them to you, right? Okay, I will go into detail later how you can actually retrieve these numbers, to find the spots that you want to show to your users. Okay, so for now we just run this sample, and no surprises again. It just brings us to that spot. Okay. Okay. Now one thing to note is I didn't specify the orientation here, so it just continued using the orientation that it was using before I called this bunch of code. So if I'm looking straight down here and I run it, I'm still using the same orientation. Okay, and this is a common principle in Germanium. Whenever you set something, only that thing you're changing will change. The rest of the world will stay the same. It's typical programming design. Okay. Now, however, there's something bad with taking this approach for bringing people to some place. What actually happens is, if your user is looking at some place, let's say for some reason he's looking at your car park entrance, when he started, he was zooming out, and for some reason he ended up looking here. If you run a piece of code, which just sets the target position, what happens is this. He has completely lost his orientation. He doesn't know where he's looking at in the building right now. Okay, he has forgotten where he knows where he was, but he didn't know how to get from where he was to this place. Okay, so instead of directly setting the target, what we recommend is using the glide function. Okay, and let me just demonstrate the glide function first. So if I were actually looking at the car park entrance, when I glide, it moves, Germanium brings you from where you are over to the destination. Okay. Now the glide function looks like this. It's a glide. It's also in the eye, and we are asking the target to glide over to the same position we saw earlier, okay, and at the same distance of 5 meters. Okay. So let's look at how the glide function is formed and how you can specify it. How you can call it, sorry. Okay, gliding. For gliding, there are 2 types of glide functions. Okay, the first type is looking at or from some point. Okay, so in the case, the example just now, it was looking at a point in the meeting area. Okay, the second type is when you're looking at something. So the something could be a level, a placemat, or some other bigger object. You just ask Germanium, I want to be able to see the whole of level 2, and Germanium will do that for you. Okay, and these 2 types, they fall under these function calls. So the glide target to and glide eye to are for looking at and from somewhere, and the glide eye to fit is to look at something. So you pass in the object you want to fit in Germanium. The function call itself looks like this. The parameters are specified in a JavaScript associative array, okay, which is just a fancy name for a list of key value pairs, right? Okay, so you just have a curly braces here. You specify the key here. So the key is position, and the value is just 10, 0, 10. It's target distance, and the value is 5 meters, and duration 10 is 10 seconds. Okay. Now, these keys are all predefined, and these are what you pass in to Germanium. So the full list is listed in our API documentation over here. Under the I, it's specifying glide parameters. Okay, so all the parameters are listed here, So you can see for the glide eye and target, you can specify the position, orientation, target distance. For fitting, you can pass in buildings, block levels, place marks. You can control the animation, whether you accelerate and decelerate at the start, and control the speed, and some other parameters. Okay, I shan't go into right now, but let's take a look at them in action. It's much easier to understand. Okay, so let's get back to the sampler. Okay, so we have seen one glide, which is gliding to somewhere. The next one let's take a look at is gliding to something, and in this case we glide to level 2 again. Okay, so if we were down here and we run this code, yeah, Germanium goes out so that you can see the whole level 2. Okay, and this is one of the examples of the heavy 3D lifting that I mentioned that Germanium does. If you, no matter what your screen is like, or your orientation, if you run this code, Germanium will make sure that level 2 fits nicely into the view. Okay? So this function call is very straightforward. We just pass in the level 2 object into the level parameter. Okay? And in this case, since we didn't specify the orientation, we are still ending up using the same orientation the user was looking at before the function was called. Okay? So next example illustrates what if we want to show the user a specific orientation. So let's say we want to show him a looking straight down view like this. Okay, so here we have an opportunity to practice some of that 3D coordinate system. Okay, let's think about how we are going to get this orientation looking straight down. Okay, so let's start from the default orientation. Okay, there's an origin here. Okay, so if I specify 0, 0, 0, this would be the direction that the eye is looking at. Okay, but what I want is this view. Okay, so immediately it's obvious that there's a 90-degree rotation involved somewhere. Okay, right? Somehow 90 degrees must be in there somewhere. Okay, so the next step is, okay, which axis was this rotated around? Okay, so if I'm starting from here, and I'm rotating up around here, so I'm actually rotating around the x-axis, right? Yep. See, can see that some of you guys have it. Okay, and the next question is it positive 90 or negative 90? Right. So, well, we just take our thumb, point it in that direction. Okay, let's say we're guessing it's positive 90. Okay, we can see that our fingers are actually pointing forward, okay, or downward. So if we actually rotated 90 degrees, we will actually end up going this way, going down under the ground. Okay, so the answer must be negative 90, and yeah, that's just it, negative 90 degrees. And we use the degree to radian function to convert the units. Okay. So when you run it, yeah, it just ends up in a top-down view looking at level 2. Okay. Okay, next is some configuration on the speed of the glide. Okay, so far what we've been seeing, okay, is a speed that's controlled by Germanium. Germanium actually calculates how long it should take, to have a not too fast, not too slow animation speed. So if you're further away, it'll take longer. If it's rotating more, it'll also take longer. Okay. However, there are times when you may want to control the speed of this glide. Okay. So there are two options. In this example, we specify the total time it should take for the glide. So specifying 10 seconds. If I run it, it just slowly glides over the next 10 seconds to reach to its destination. Okay, so that's 10 seconds. Yeah. Okay, the other type of controlling the duration is the speed multiplier. So if you are familiar with how fast Germanium is going, you can also then configure it to say go twice as fast, or half as fast, or 1/10 as fast. Okay, this is a multiplier. Yeah, you can try it out on your own.